Everyone, this is Ahmed Jawaad, and today I'm back again with yet another video of a lesson a day. In today's class, we are going to learn quantitative chemistry, one of the most interesting, significant, and advanced chapters of O-level chemistry. So without any further ado, let us get started. In today's lecture, we are going to cover the conservation of mass, mole, and the Avogadro constant, which was named after Mr. Emilio Avogadro. We will learn the relative formula mass and some of the examples and calculations of all these. So without any further delay, let us hop on to the main lesson. So as you can see, today's first topic is conservation of mass. Conservation of mass is one of the most interesting and important ideas of chemistry. It is quite similar to physics' law of conservation of energy, and conservation of mass basically states that mass can neither be created nor destroyed, but it can be transformed from one form to another. For example, during a reaction, atoms are neither created nor destroyed. So it is quite similar that the mass of the reactants will be equal to the mass of the products. And that is basically what conservation of mass is. It states that mass is neither created nor destroyed. Now, as you will see the examples of conservation of mass, I hope the lecture I gave earlier will become more clear. So, as you can see, we have two reactions here. Magnesium plus chlorine is the first one, which gives off magnesium chloride. So, as we already know that mass is neither created nor destroyed. So, magnesium has a mass of 24 grams and chlorine has a mass of 71 grams. After the reaction, if we add the two masses, magnesium and chlorine, 24 grams plus 71 grams, we get 95 grams, which is equal to the addition of magnesium and chlorine, which is actually pretty usual, as we already know that conservation of mass states mass is neither created nor destroyed. And in the second example, we have calcium plus chlorine, which gives off calcium chloride. So calcium has a mass of 40 grams and chlorine as usual has a mass of 71 grams. So when added, the total mass of calcium chloride after the reaction, the product has a mass of 111 grams. So as you can see that the reactants and the products, they both have the same mass even before the reaction and after the reaction. So these are the examples of conservation of mass. And through these reactions, you can clearly see that mass is neither created nor destroyed after a reaction. Now we have come to the most important and interesting lesson of today's lecture, the mole and the Avogadro constant. So before a reaction, chemists cannot literally weigh or count every single atom before putting them in an experiment or a reaction, right? It is quite impossible or literally impossible to do it. So to sort this problem out, after many researches and experiments, scientists came out with a standard unit. And that standard unit is known as mole. What a mole is that it is a collection of many atoms together, counting to exactly 6.02 into 10 to the power 23. So let's say 1 mole of carbon is put into that reaction. It means that 6.02 into 10 to the power 23 atoms are put in that reaction. And this is constant for every atom out there. For example, 1 mole of lithium, it means 6.02 into 10 to the power 23 atoms in that reaction. 1 mole of iron, it means 6.02 into 10 to the power 23 atoms in that reaction. And this thing is constant and is known as the Avogadro constant, which was named after Mr. Emilio Avogadro in the 19th century. So 1 mole of every atom is equals to 6.02 into 10 to the power 23 atoms. Even though 1 mole of atoms for every atom in the planet is equal, the mass differs. This is because the relative atomic mass of different atoms is different from each other. But the relative atomic mass is equal to the mass of 1 mole of an atom. So let's say the mass number or the relative atomic mass of carbon is 12. So 1 mole of carbon has a mass of 12 grams. This is similar for all the atoms. In brief, 1 mole of a certain atom is equals to 6.02 into 10 to the power 23 atoms and its mass is equal to the mass number of that atom. So that is what Avogadro constant is, and that is what mole is. Now let us look at some of the examples. As I previously said, that the mass of 1 mole of a certain atom is equal to the relative atomic mass or mass number of that atom. As you can see in the first example, we have carbon, which has a relative atomic mass of 12, and that's why 1 mole of carbon is weighed at 12 grams, and it has 6 into 10 to the power 23 atoms. And then we have lithium. Since lithium's relative atomic mass is 7, 1 mole of lithium is also weighed at 7 grams. Now let us know how to calculate relative formula mass is. But before that, we need to know what relative formula mass basically is. Relative formula mass is basically the relative atomic mass version of compounds. And relative formula mass is basically found by adding the relative atomic mass of the reactants that form that compound. In the reaction, you can see, in the example, you can see that we are supposed to find the relative formula mass of ethanol. Ethanol has a formula of C2H5OH. So how to find it? Let's see. So look, first divide this formula within elements. So we have carbon, C2, we have hydrogen, H5, then oxygen, O, and then again hydrogen, H. So look, carbon has a relative atomic mass of 12. Since there are 2 carbons, 12 into 2 it's 24. Then there are 5 hydrogens and the relative mass of hydrogen is 1. So 5 into 1, 5. Then oxygen has a relative mass of 16. So 1 into 16 is 16. Then hydrogen 1 into 1 is 1. And then to find the relative formula mass, we will add the relative atomic mass of all these elements. So let's add 24 plus 5 into plus 16 plus 1. We get 46. So the relative formula mass of ethanol is 46 gram per mole. And remember one thing is that the unit relative formula of mass is gram per moles. Now with this, we have come to the very end of today's lecture. I hope you liked today's lecture. I tried to do something different, something new, as we were studying the most basic chapters of chemistry. That's why I thought of bringing out something new, something interesting. I hope you liked it, and if you have any queries, please note down in the comments below. This was Ahmed Jawaad signing off from A Lesson a Day, and I hope that you'll be waiting for the next videos. Thank you so much.